Yeah, so let's look at the homework series part two. Just like the last one, I'll try to cut this up into multiple parts, and so no one runs too long. Let's just get into it. All right. So I don't have a compass and straight edge with me, but we can certainly kind of sketch it out and kind of envision what that would look like. Um, and so we had to sketch AB, map it, which means to copy it to another segment, A prime, B prime. And so what we start out with is just basic constructing a segment. So we have A, and then we have B. Now, in terms of copying this now to using a compass and straight edge, the important thing to observe is how many distances, in other words, how many radiuses you're going to have to keep maintain using your compass. Now, this being a 1D figure, it's really just going to be a single distance. In other words, just a single circle. So we can definitely simply copy A to A prime. Since it's just a point in 0 dimensions, it doesn't really matter where it goes. Now, in terms of setting your compass, and I guess I'll try to sketch this out. We have to use a compass to kind of grab this distance AB and then transfer it to find B prime. So we can pin our compass at A prime, and then we're going to have to cut an arc. Now, this has been a point of contention, exactly why we need this arc, but let me try to make it as clear as I can. If you're not showing me this arc, I don't know if you're actually copying the distance or you're estimating it. Now, I know I'm technically estimating it here because I don't have a compass I can use electronically on my iPad here. But if you're trying to make a copy, if you're trying to make a map, it's not a guess. It's an actual tool-based method to try to. Ooh, not what I thought. It's an actual tool-based method, and so what we're really saying is like anywhere on this circle, anywhere that's length AB, we can copy. And so it doesn't really matter where you copy to. I'm going to copy just to there, and that should work just fine to find our B prime point. But when we're copying an angle, that's going to be a little different. So first, let's kind of map out this JLF angle. So here's J, here's L, here's F. Here's our first angle leg, here's our second. Um, when we're mapping this out, the first part is actually just like the segment copy up here. We can pick any point L. We grab this point, or we grab this distance right here from J to F, and using our compass, find an arc, and then pick a point to call F prime. Again, prime just means it's a copy of the original. And again, it can kind of exist anywhere that's on this circle. That's a distance JF. But that's not really the interesting part. The interesting part is when we go and try to find J. So if you think about where J is relative to L and F, there's actually two distances here that you have to observe, or you have to respect or maintain. It's got to be the distance to J, but it's also going to be this distance to F. Because if you think about what J really is, it's a point in space in 2 dimensions. I'll call this distance 1 and distance 2. This is like the distance 1 away from L, but it's also the 2 distance away from F. And so the reason why this is important is because this tells you need to maintain 2 distances in order to find this. Now again, this is just roughed out because I don't have access to a compass, but we have to find the distance 1 and kind of find some potential locations for it, and then we'll do the same thing from F to J, and where that intersection point is has to be our new J prime. This has been a consistent theme for us about in terms of the constructions, and it's really all about indirectness. I can't just find a distance to J. I have to indirectly find it using multiple distances to help pinpoint that location. Okay? Here again, we have more compass and straight edge, but again, I don't have anything to do that with. We can kind of talk through it. And so first, we need to find the line AB, and we have to observe it's a line, so we need arrows there. And to find the C, so it's not collinear, so C looks like a good place here. And then we want to construct the line so it's parallel. Well, again, this is about multiple distances. And so if we're going to find this point, use point C prime, we have to observe that there are 2 distances involved. This one from C, but also this one from B. And if we can replicate those distances, in other words, we can use a compass to grab the red distance and kind of find an arc from B. Then we find this blue distance, but now we're actually going to find it from A. Where those 2 intersect should be a C prime point. The interesting question that was raised is actually why this turns out to be congruent. I'm sorry, turns out to be parallel. And it has to do with these distances. The best way you can put this is that if you kind of accept these points are fixed by the blue and red distances, then you also have to accept that the distance straight down to the lines have to be fixed as well. And so even though we never found the green distance, we can reason the green distances have to be the same because of the red and blue distances. Two distances fix C, the same two distances fix C prime, and so these distances, which I'm labeling with an X, well, they have to be the same too. They have no choice. Even though we never directly found them, indirectly, that's going to be the case. The perpendicular bisector is kind of like that last one we did. Oh, my pen's falling apart. Okay. And so we have this JK. So we have to find points that are bisectors and perpendicular. The perpendicular just means we got to use the same circle each time. The bisector part means that we have to make sure that we're the same distance away from J as we are from K. And so if we pick like a single radius distance, it doesn't really matter what it is, and then we take some arcs, one from J and one from K, the intersection point between the two has to form a perpendicular bisector. Okay. Now, even though what we're really interested in, to be quite honest, is really this point right here, we can reason that it has to be a perpendicular bisector, at least on the perpendicular bisector, because of the behavior of the points around it. And so even though we didn't ever construct the blue, we know that the purple point here is the same distance from J to K, and this other point here is the same distance from J to K. And so it's not a difficult jump to say, well, if these two purple points are in between J and K equally, that means this middle blue one has to be as well. And that's really what it boils down to. It's not so much that we're looking at it and saying, well, this has to happen. There has to be a reason behind why it's happening. Whether it's like two distances fixing themselves for C and C prime, and so they're both the green distance away from the purple line, or the fact that we're using one circle, one radius, so we find two purple points that are the same distance away from J and K, and so the blue one has to be as well. Okay. This last one is going to be actually incredibly hard to copy not using a compass on paper, but we can kind of notice that since we're mapping this shape, what we're really accomplishing is a combination of 1 and 2 in the first question. This shape is composed of angles and side lengths, and so no surprise here, we have to copy angles and side lengths. Now again, kind of roughing it out, if I want to copy A, that's really not that big of a deal. A is just a point, so certainly I could just pick a point A, excuse me, prime. In terms of finding the distance to B, well, I have to respect the distance AB here. That means I have to use a single arc, a single line, to find my B prime point. Okay. Now from here, though, what we have to be able to do is copy a bunch of angles. And so we have these angles that we need to copy to get the D point and get the C point. And so just like original angle copy here, we're going to have to use two distances each. What I mean is, if we want to find where D is, we're going to have to use not just one distance, but a second distance from B. And so we're going to have to, again, see two arcs, one from A and this other from B. I'm just roughing it out. I expect you obviously to use a compass. But once you find those two distances, you can reliably now map a new D prime point. Same has to hold true for C here. To find C, well, we have to respect the distance from A, and we have to respect the distance from B. And so again, we expect to see a couple different marks, one for the C distance A, and then another one here for the B distance to C. But again, once we do that, we can reliably map out our new C prime point and map out the whole figure. Now, there was some concern raised about whether or not you're going to have to be perfect. Well, you're going to have to show that you use a tool and try to be as perfect as possible. But one conversation we're going to have in the future is how perfect these tools really are. Okay? And so, even though that's not a conversation for now, that should lend itself to thinking, well, as long as I can reliably see your technique and I can reasonably tell you try to make it as perfect as possible, that's going to be good enough for now. Okay, so that's the end of part 1. I'll see you guys in part 2.